All right, folks, welcome to this month's meetup. See, a lot of people are trickling in the room. I never know Zoom if it's actually letting in people one at a time or it's just iterating the counter to make it look like there's activity to cover up some sort of server lag or something. So let's give it a little bit for everyone the counter to keep ticking upwards, and we'll get started in just a few minutes. In the meantime, we could all sit here awkwardly staring at each other in silence, the four people on screen, or we can make small talk banter like, who's that coffee clutch on SNL? The clump lady? No, you know the answer.
I do not.
A peanut's neither a pea nor a nut discussed, and she's all verklempt. It's Mike Myers plays her.
Nope, no idea.
Someone from SNL knows this. Hi, Jim from Chicago. Thanks for joining us. Where else is everybody else from? Let us know where you're from. Jump in here and tell us where you're coming from. So now that we're all virtual, people are coming from all over the world. We have people from all over the states and other countries, depending. I did say, and I'll make this announcement again later. Valentina, still in NYC. I like to see that. We have Collins, Colorado from Brian. And we have a Slack channel. Amada posted the link in there to join it. And you can go ahead and use a Slack for conversation, as we'll go over in a little bit. Some names are getting cut off. I see San Francisco, the other Williamsburg. I like that. Maybe the original. Actually, I don't know which Williamsburg is older, because like Williamsburg, Virginia does have colonial Williamsburg, but Williamsburg, Brooklyn goes back to the Dutch days, so it's kind of hard to say which one is older. I'm sure someone has that answer here. Melbourne, someone from Melbourne, nice. I can't see the full name though, but that's probably going to hold the record for the farthest away. San Francisco, Jersey. Very cool. Oh, New Haven, of course. With their facsimile of New York pizza, but they're going to call it pizza, and it is pizza, but it's a pizza, but it's no New York pizza, even though they use a coal oven. All right. Okay, so why don't we start slowly with the announcements? So I see Amada posted again. If you're in here, join our Slack team. You can get to it by going to the link. Amada posted 2 links. You get to it from either one, nyhackr.org/slack.html, or go directly to the Slack invite link. Go on there, and this beyond tonight, we have all sorts of community announcements on there. All sorts of information is available on that Slack team. So before we get going, first things we always like to do is we always like to say who's hiring. But during the pandemic, we can't just have everyone sort of shouting in here. It would be a little too difficult. So if you can go into the Slack team that Amada sent a link to, and there is a channel specifically called job postings. Go in there and post your job and tag it that you're here tonight. We also have a channel for tonight's meetup. I believe it's called November 9th meetup, roughly along those lines. And you can post jobs there, but I highly recommend putting into the job postings also to catch everyone. One of the nice benefits of EcoHealth Alliance sponsoring us every month by providing the Zoom link is that Noam has some jobs he'd like to announce, and since he's right here with us, he helps host us every month, he's going to say some of the jobs he has waiting for everybody.
Sure, thanks, Jared. So EcoHealth Alliance is happy to have been New York R's virtual host for the past 7 months or so. When we were in physical space, we weren't able to fit you all into our offices, but now our home, we're happy to provide a little infrastructure for everyone. So EcoHealth Alliance is a nonprofit based in New York City that works on pandemic prevention and wildlife conservation. And we work on emerging infectious diseases globally and locally. And right now we have a bunch of job opportunities at EcoHealth, ranging from a data scientist position on my team to more intro level positions of project research assistants and research scientists, all of which have R as some component of the job, from project managers for whom some data management and some analysis is part of the portfolio, to data scientists who will primarily be coding and building infrastructure, data pipelines, and models for coronavirus modeling and response. So I'd encourage anyone interested in environmental or public service or public health fields to check out the job postings I just put in the job channel. And feel free to contact me on the New York R Slack if you have questions about any of them. These are the ones up now. There will be several other new ones in the coming months, so do keep an eye out. Thank you very much.
Thank you, Noam, both for hosting us and for the jobs. If you can imagine anything right now, a organization that helps prevent pandemics, global pandemics, I think that's a really great place to work right about now. So thank you also for trying to prevent or lessen the pandemic also. Everyone, give Noam a virtual round of applause for getting out ahead of this. Those of you who don't know, we actually gave our first pandemic talk in April virtually because he's an expert in this stuff. So thank him for all the work he's doing. And I'll see if everyone's hopefully virtually clapping for him in the chat. Thank you, Noam.
Thank you.
Yes, it's great having it. Again, everyone also thank you EcoHealth Alliance for sponsoring us, everyone, hosting us. It's really a big help having them do it, so thank you on that. People who have been coming to this meetup for a while know that we really take our pizza seriously. So if everyone is having pizza virtually, this month I got it from Newtown Pizza. You can see I got like a cheese slice, and what they're various historical reasons. So this is Newtown Pizza's facsimile of a Trenton pie next to their plain slice. You can see there's decent charring on the back considering it's a gas oven. Not cold charring or wood charring, but it's good for a gas oven. So I hope everyone's enjoying their pizza wherever they're getting it from. And let us know in the chat where you're getting pizza from this month. We always like to know about that. It's always fun. I know Amada got Williamsburg pizza recently, and we'll see where everyone else is getting pizza from. Well, let us know. It's always fun to chat about pizza. As I was saying earlier, we can't all ask questions the way we normally would. I'm just gonna put the pizza down for a second. Sorry for the weird leaning over. We can't all ask questions like we normally would in person. So if everyone can meetup channel, ask your questions in there, and we will collate the questions and ask them later for you. Depending on how many questions we get in the middle, we might ask some questions in the middle of the talk, or we might save them for the end. It depends how the talk's going. There's a lot of questions people need answered. We will work on the best way either during the talk or after and get all your questions answered. So please go ahead either in the Zoom chat or in the meetup chat and let us have your questions. We have the next few months planned out in terms of meetup. We actually have a pretty full schedule, but next month is our big R week. Normally, in addition to the New York R conference every spring/summer this year, we have a Washington, D.C. conference. Since we're not going to be there physically, we're doing it virtually, just like NYR was, but it is actually very more focused, less on the geography of D.C. and more on the concept of D.C. and government in general. It is now the R in Government and Public Service Conference, and we have a full week, almost a full week packed of activities. To kick off our week, we have December 1st. We have Will Landau talking about the targets package. If you came a few months ago for Miles McBain's talk about Drake, Will wrote both Drake and targets is the future replacement of Drake. That'll be December 1st. We're really excited. Then December 2nd will be a day of workshops to go with the R in Government conference. We have 3 workshops. We have Malcolm Barrett and Lucy D'Agostino McGowan teaching a workshop on causal inference. We have Kaz Sakamoto teaching mapping for public policy, and John Hirsch teaching machine learning for public policy. So that's December 2nd. And then December 3rd through 4th is the actual R in Government conference. We have speakers from NASA, from the Census Bureau, from the Department of Defense, from Canada's Defense Ministry. We have people from New York City Department of Health and Human Services. We have, I think, some educators. We have people from Zurich, I believe, working on COVID. We have people from all over the world speaking all about public policy, whether that's federal, state, local, provincial, different countries, different levels of government. It's going to be a really exciting conference. We're really putting a lot of hard work into making this as lively as NYR was. We, instead of a whiskey sponsor this time, we have a rum and gin sponsor. We have a panel. We're going to have a lot of cool events. We have the art auction. We already have a bunch of art being donated. And just like NYR, all the proceeds from the art auction is going to be donated to the R Foundation. So the money goes to a nice cause I think we all believe in here. If you want to learn more, you can go to rstats.ai/gov. I believe, oh, Ahmad already posted the link. Great. And you can use discount code NYHackR for a 20% discount. So go to rstats.ai/gov, use your 20% discount, and come have a fun time. I think anyone who comes to my conferences knows that they are fun and informative. So we're going to have a really good time. All right. With that, we bring our speaker who is on the R Foundation, which is a nice segue, and is on the R Consortium, and is coming to us all the way from the West Coast to talk to us about futures in R. So please, everyone, give a warm welcome to Henrik. Thank you very much for being here, everyone. Thank you very much.
Thank you so much. Hi, everyone. I'm going to share my screen here. There we go. Got to clean up. I'm very grateful for giving this opportunity to talk. I wish I could see you all in person. As probably a lot of speakers been saying on virtual talks, it's kind of awkward to speak into the void, but I know you're out there listening. So I'm going to talk about the future package and the future framework. It's meant to be a simple, friendly framework for parallel processing in R. My background is computer science. I did a PhD in mathematical statistics through various places in the world, including wonderful Melbourne and Weihai. And Berkeley, I ended up at UCSF in San Francisco. So I'm in the Epi Biostat department where I'm a faculty there. I spend most of my days on cancer research in the cancer center there. And I do a lot of computational large-scale processing. So what I'm presenting here, I would say, grew out of work that started back in 2005. I tried to parallelize on my Windows computer at the time, then Linux. I had collaborators all over the world, and we developed methods for microarray data sequencing. And our methods in R, we wanted them to work for everyone. So slowly, I added parallelization frameworks and I built up things. And this is kind of the final product of those things. You can find me on Twitter, GitHub, and I have a blog post to jotter.org where you can see a little bit where I'm blogging about the future framework. Okay, so why do we parallelize? We parallelize things when we try to speed the existing code up as much as possible, and we can't get the results faster. So then we look into can we run certain things in parallel here? So this animation here is actually pretty good. If you look at this, there are both parallel tasks and sequential tasks going on here. So each of the wheels are replaced. But if you look at one of the wheels, they unscrew the wheel, they pull off the old tire, they put on a new tire and screw the new tire back on. So a lot of things can happen in parallel and things can happen in sequential, and we can orchestrate that. And we can do that in R, we can do it with the future framework 100%. So why do we parallelize? So one thing was, I said, is like to speed up processing time. So things finish faster, the wall time is shorter. Other things we do is when we have very large data sets, we might not be able to process all of the data on a single machine. We can do it, we can chunk up the data and process sequentially each chunks, but we can also take the chunks and distribute them out to multiple machines and have them run at the same time and bring back the results later. There might also be other reasons like asynchronous user interfaces like Shiny in R. So there are different reasons, but the most common one is to speed things up. Okay, so I don't know your background, who's listening out there. So I'm going to try to cover what's already available in R. And back in 2014, we got the parallel package that's distributed with all R installations. So we all have this available. So, but let's start. Let's take this toy example. We have a list here with 3 elements, A, B, and C, and each of these elements contains 50 integers. And we've probably all been here from the first day we started to use R. We did things like this. We wanted to calculate the sum of each of these elements and store them in a new list. So we created a list, we calculated the sum of element A in X, assign it to A in the Y list, and so on for B and C. And then quite soon we realized, okay, if there are new elements added, this is not going to work very well. So then we turned to for loops. And this is a pretty good for loop. We create a list, we iterate over all the names in the X list, and then we calculate the sum for each of these elements, and we assign it to the Y with the same name. So this works. It's very verbose. It depends where you're coming from. You might like this. Some people might think it's too much code, too much clutter, but it's very clear what it's doing here. And then we know in R, there are apply functions. So in base R, we have the lapply function, the list apply. So the same task can be done with this. We call lapply on the vector capital X, and we say apply the function sum and return a new list in Y. So all these alternatives will give the same results here. And one thing is interesting to see here, it's that the lapply, when you just look at it from the outside, there's nothing saying which order things will be done. It could be that lapply decide to do it in the order of B, C, and A. As long as it returns it A, B, C, we're all happy. Okay, so R has the parallel package. So if, say we have this function called slow sum, so we calculate each of the summations of the elements will take 1 minute. So doing it from 3 elements will take 3 minutes if we use lapply. So we can use the parallel package, and there is the MC lapply, which is multi-core lapply. So that's how you use this. And here in this case, we're saying let's use 3 cores on our local machine. And since each of the tasks will take 1 minute each, and they run in parallel, this will now finish within 1 minute. And this is good if you're in Unix or Mac, but if you're on Windows, this will fall back to a regular lapply. And this is because it's using fork processing, which R doesn't support on Windows. However, we have options to parallelize also on Windows. Or if you want to do something that works on all operating systems. So this last example here works on all operating systems, where we create a cluster of 3 workers. We pre-create it, so that actually launches 3 processes that run in the background and are ready to serve tasks that we send them. And the way we send those tasks is for the parallelization function. So it looks very similar to lapply. We just specify what the cluster is, the cluster of workers. And this was also run in parallel for three tasks at the same time, finishing 1 minute. So this is good. There are a few things we need to be aware of. Let's look at the MC lapply. So it's great because it looks exactly like lapply. It comes with all R installations, so you know it's there. And one thing I will return to later, it's like we don't have to worry about global variables and loading packages. It just works. And the reason why it works is using this concept of forked processing that is a construct in the operating system. So everything is taken care of automatically by the operating system. And that's the unfortunate thing. It doesn't work on Windows. Another thing is there are cases where this might actually crash or core dump your R session. It's not 100% clear when it is happening, but there are several reports coming in. And I'm saying it's not clear. It's not clear to me. There are people that knows very well how this works. But we see this is like when there is code that is multi-threaded, and multi-threading is something that's done in native code. It's not done at the R level. So there's already a multi-threading going on, and then you parallelize on top of that. There might be things that doesn't work when you do fork processing. And there are also like the environment you're running in. So for instance, people have been saying that the RStudio console, you might actually crash that if you run MCL apply. Not all the time, but in some cases. So MCL apply is kind of, you have to know, you have to use it with care. And this is a quote from April 2020 from Simon Urbanek, who wrote MCL apply and is part of the R core. So he said, do not use MC parallel. That's one of the functions in the multi-core MC apply structure. Don't use that in packages except as a non-default option that users can set. So that means if you have a function, you should not, one thing, you should not run MCL apply by default, and then should be the choice of the user. So then you can, as a developer, you can be sure it will work. And the ones who want to take the chance to try it, they can try it. And it's meant for HPC application that need to use many core as possible for computational heavy jobs. But it does not play well with RStudio. And more importantly, you or we as developers don't know the resources available that the user has. So only the user can tell you when it's safe to use it. So I just want to raise that. It's like, it's a wonderful function, but you might run into very complicated, hard to troubleshoot errors. Okay, let's look at the parallelization solution, which works on all platforms. Just like MCL apply, it works very similar to lapply. Comes with all our installations and all operating systems. The drawbacks here are like you have to manually load packages on the workers you create. And you also have to make sure you export all the variables and globals to the workers. I show you an example here. It's a bit convoluted, but bear with me. It's a toy example. So in the dplyr package, there's the Star Wars data frame of Tibble. It contains the name of the characters in Star Wars, their height, their weight, homeworld, and the species. So let's say we want to calculate the average height on all the humans and the average height of all the droids. So, and this is what I mean. It's a toy example because dplyr can do this very well, but here I'm going to use lapply for this. So I'm going to lapply over the droid and the humans. So I'm going to pass a function that takes those as an argument. And then I'm going to use the filter function in dplyr on the Star Wars Tibble and subset either droid or human. And when I've done that, I'm going to take out the column height and I'll calculate the mean value and removing missing values. So if I do that, and then I look at the unlisted version of the result here, it's going to be the mean height of the droids will be 131 centimeters, I guess, and the human is 176. So if we try to do this same thing with parallelization, it looks very similar, and we just replace the lapply with parallelization. We're going to get this. The workers or the nodes will complain saying, I don't know what this Star Wars object is. And if it knew that, it would start complaining about the filter. This is because we need to tell each of the workers to load the libraries, dplyr. So this is how we do this. We do a cluster evaluation across all the workers and say load the dplyr package. And now it will work. Okay, so we need to load packages. Here's another example of this from this example. Let's say now we create a utility function called average height that encapsulate this complicated expression that we subset, etc. And we try to reuse this in our parallelization internally. So that's a neater expression, cleaner. And it worked before, so we expect this to work again, but no. Now the workers are going to complain that I don't know what average height is. And that is because that was only defined in your local environment, your main R session. And what's evaluated within the parallelization is running on the workers. So we need to pass that function. We need to export that function. And then it works. So parallel is nice, but it comes with this extra orchestration and clutters up your code a little bit. Okay, so let's see then. If you're a package developer and you want to like support parallel processing, I've gone through what I'm going to show now. If you pull out a package in CRAN that uses MCL-apply or parallel-apply or both, you will see what these examples. So the first one is like, so let's say you have a function call. Let's go back to the slow sum now. Forget about the Star Wars. So we want to calculate the, we call slow sum on each of the elements on an X, and then we take unlist and sum that. So that basically is a function called total sum. So if you have this original list with 3 vectors, we call total slow sum, and we're going to get the sum of all these. And it will work by its first summing 1 to 50, 51 to 100, and then this, and then take the sum of those. Okay, so now you have this as in a package on CRAN, and you want to, since it's slow, we're looking into parallelization. And this might be the first iteration. So this is quite common thing you see on CRAN packages. You add an option that the user can say parallel equal to true or false, whether they want to parallelize or not. And the way we do it, if parallel is true, we call MCL-apply. And in this example, it's saying calls the detect cores that use all the cores in the machine. And if I forgot to say that later, don't do this. This is bad habit, not very friendly. And if you don't run in parallel, we fall back to using lapply. And then we end by summing of these intermediate results. So from the end user's point of view, it's very clean. You call total slow sum, and the end user can call either parallel equal to true or false, and they will get the same result. And then, so here's a better example. I said don't use detect cores. It's actually better to just don't specify that and let the user specify the number of cores for an R options. So then the user can control exactly how many cores they want to use, if they want to spare some cores for other tasks, etc. Okay, another style you can see, it's that instead of having parallel equal to true or false, is that you package developer provide an argument called ncores and saying how many parallel cores you want to run. So the default is 1, and that means it will fall back to use lapply. But if the user specified 2, 3, or 4 more, they will run with MCL-apply. And regardless, you get the same results. Okay, so then the Windows users. So now we want to support Windows users too, because we don't want to leave Windows users out. And so this is what the code will expand to. If the user asks for more than 1 core, then you can check, am I running on Windows? Yes, then we can create a cluster with n cores workers. We're a really good citizen here. So if this function, when this function exits, regardless if it is an error or successful, it will shut down the cluster at the end. If this slow function would depend on some library or globals, they have to be exported as well. And then we call parallelization. If you're not on Windows, that is like Linux, Solaris, or Mac, we can use the MCL-apply forked. Or if we don't want to do parallelization, we fall back to lapply. Okay, fine. And then you're sure going to get users if your package is popular. Hey, can you please add support for the AAA parallelization method too? And then someone else is like, oh, while you're doing that, can you add the BBB support? And if you look at this, the previous example, this parallelization is all on your local computer. So the first thing you might actually get requests from is to parallelize across multiple computers. So we need to adjust this code for that. So you might end up with something like this. Now you don't longer have true false. You have a string where you specify what type of parallelization. So you can parallelize with snow. That's the general term for these parallel apply solutions. And here is a way you use whatever the end user has set. You load packages, export globals, and you call this across the workers. If the user requested multi-core, use MCL apply. Maybe someone want to use the cluster MQ package backend, which allows you to parallelize on HPC, and that has also arguments for exporting globals and loading packages, or there might be other parallelization backends. And finally, if we don't want to parallelize, we do the sequential. So, and this is not just toy examples. You will find packages that do this, and I did this in the beginning back in 2005, and my package exploded. I created utility function to encapsulate this, but it started to become tedious. And then after a while, you say, I'm adding all these things, but I can't test all these parallel backends. I don't have access to them. So you start wondering, what's the test coverage here? I mean, I might trust the MCL apply because I'm on Linux. I can run this and I can run this, but I might not have access to these. So these are, like, for me, unknowns. And if it's unknown to me, I can test them. It's an unknown for the user. So it will be risky for the user to run this, because in the end of the day, key thing here is, like, we always want to make sure we get the proper results back. And of course, even if you're happy, 5 years from now, there will be someone come, hey, there's a new cool parallelization method out there. Can you add this? And I'm sure there's a lot of package developers that will ignore those requests. So it's a tedious thing when you want to start supporting parallelization. So the summary of this is basically that as a developer, you want to say, you need to know what parallel APIs are available and which one should I use, what operating system are the users running on, and you might decide, I don't have access to Windows, I can't be bothered to develop and test on that. Or you get requests back and you're like, oh, it should have worked, but then, oh, I didn't test on Mac OS and there's something weird there. And likewise for the users, they will say, I wish the developer could spend time to just add MCL apply option or something like that, because this awesome package is too slow, but if you can parallelize it, it's great. And there might be people on Windows users that can't parallelize. And also the fact that the test coverage is, like, you see this a lot on Stack Overflow. Someone posts an example and users say, it doesn't work for me, I get this error. And others say, funny, it works for me. And there's a lot of discussion back and forth before they figure out they're actually running on different operating systems that cause slightly different differences. So there are some tedious things we have to deal with. Okay, so this is the reason why the future framework came about. I'm going to take a break here to drink. Okay, so the future framework is implemented, the core of it is implemented in a package called Future. It's the motto is write once, run anywhere. It's targeted to be 100% cross-platform. Supposed to work with any type of parallel backends. I will return to that, what that means. It's supposed to be as simple as possible unifying API. And there shouldn't be much more than what's really needed. It's very easy to install. It's small. And I say it's very well tested. You get lots of CPU mileage. And for developers and users, it's supposed to provide low friction. So for instance, we saw the global variables. They are automatically exported, identified. Output from print and things like that, and message and warnings. They are relayed and shown properly. And there's a concept I won't cover today, but feel free to ask about it. It's random number generation, because that's a very important thing if you do statistics and you run things in parallel. So what is the future? So first of all, I didn't invent it, I reinvented it or rediscovered it. It was invented in the mid-70s in the field of computer science. So very theoretically, a future is an abstraction, it is a programming construct for a value that will be available at a later time. The state of a future is either unresolved or resolved, and the value of the future is the result of an evaluated expression. So this is a little bit like a Schrodinger's cat. We basically put an expression in a box and we close the box, and we don't really know if it's resolved, unresolved, or the cat is alive or dead. And then when we open the box, then we know. So if you look at R, let's look at a very simple construct in R. That's the R assignment. So it has a left-hand side here, the letter V, an assignment operator, and a right-hand side, an expression. And this expression can be simple as 1 plus 2, it can be function call, or it can be a bigger construct. But the key here, when R sees this expression, it gets to this line of code, it takes the right-hand side, evaluates it, and assigns it to the variable named V. And it does that in one step. So if you look at the future API, it splits this up in 2 steps. So you create a future of the expression, the right-hand side, and you say, here is an expression, please evaluate it, and you get a handle back to F. And the thing is that we don't have to ask for the value if we don't want to, but later in the code, maybe the next line or much later, we say, please give me the value of this future. We're going to get the value back. And by splitting up this very simple construct of an assignment into 2 steps, we can do a lot of powerful things. I will show you next. So if we go back to the slow sum example, there we know that if we calculate the sum of 1 to 100, it will take 2 minutes. So and because of how addition works, we can split them up, divide and conquer. Not all problems can be done this way, but we can. Sum of 1 of 100 can be done in 2 steps. The first step is to calculate the sum of 1 to 50, which will take about a minute. And we assign that to A. And we can take the sum of the last 50 values and assign that to B. So we didn't gain anything in performance here, but we managed to split this up in 2 parts. We divided the problem. And we can sum it up later, and we get the same results. So with futures, we can do this. So we load a future package. We tell it to use multi-session. That means parallelize on your local computer. And instead of calculate the value immediately, we say it calculated in a future. And when we do this construct, it will return immediately. And since we run this in parallel, this calculation will go off in a background R session and start running. And then we can do the same for the last 50 values, and it will return immediately as well. And at this point, we have 2 background R processing doing its calculation. And our prompt in the main R session is free to do other things, so we can toy around here. And then when we board, say like 45 seconds later, we say, okay, what's the value of the first future? That's how we do this. We say, given the value of the first future. And since we only waited 45 seconds, that one needs another 15 seconds to complete. So after 15 seconds, it will return. And then since we can do the same for B, and since that ran about the same time, it's already done. And now we can calculate the sum of those things. So what we gain here is that now we get to the result already after 1 minute. So the construct of a future managed to spawn things off in the background, and then we have called the function value to bring back the results. And if you think this is too verbose, there's actually something called a future assignment operator that will allow you to do this. So when we do a future assign slow sum, this will be created with instantly and spawn off in the background. Same for B. And technically in R, these are promises. And the promise in R, as long as you don't touch it, nothing will happen. But as soon as we touch it, the promise will go and resolve the future. So it will internally call value of A. If I touch A, if I touch B, it will call value of B. And if I say A plus B, that will, like this, they will block until A and B are ready, and we get the results. But this almost looks like regular sequential code, but it runs in parallel. And key thing here, it's the end user that chooses how to parallelize. So if we don't specify anything, everything runs sequentially. We can say, the end user can say, I want to use multi-core. That's the MCL apply machinery. They can use multi-session, which is the parallel apply machinery. If they have access to 3 local machines on the local network, and they have SSH access to that, and they can run R over SSH. This one will set up 3 workers on 3 different machines, and these expressions here will now be run on 2 different machines. You can also parallelize, have 1 local machine, 1 at the university, and maybe 1 in the cloud. You can have multiple in the cloud, etc. If you have access to high performance compute clusters, you have so-called job schedulers there. There's a backend from the batch tools package. So here's like what it would look like if you would use a Slurm scheduler. So the end user would just say, I want to parallelize this on a job scheduler. You can use the call R package, which is very similar to the multi-session, but it has you can run more parallel call R. This one has a limit of, multi-session has a limit of 125 workers. That's an R limitation. With call R, you can have more. Okay. So what about global variables? So I said that global variables are taken care of automatically. So how is that done? So it works automatically. It works worry-free in most cases. There are corner cases that people run into, and we try to fix them, and some of them we can't fix. So in the cases where we can't fix, I just want to say here at the very end at the bottom, you can provide guidelines to the package to help it. If you don't like the automatic one, you can explicitly specify everything, or you can say ignore this global variable or make sure you get this one. So I think the API supports whatever you like to do here, but the default is to do it automatically. And so if we have this code example that we draw 100 Gaussian random numbers and assign it to the vector x, and then we calculate slow sum of that random vector, and we do that within a future. So this might run locally, parallel locally on your local machine, or it might be running in the cloud somewhere in the world. So what the future framework does, it do a static code inspection of this. And this is an example if you use the prior package, what it actually looks like. There's the abstract syntax tree of this R expression. It contains the curly brackets. So that's these two together, the left and right curly brackets. Next, it sees a function call where the function is slow sum, and the first argument is x. So by walking this abstract tree, it can go free. Okay, the curly brackets, that's part of base R. I don't need to worry about that. Function calls, I don't need to worry about, but slow sum, that might be something I need to figure out. Do I need to export it or not? And if it finds this as, yes, it needs to be exported, it exports it. X needs to be exported. And this process is also identify what namespaces needs to be loaded on the workers. So that's how global identification is taking place. Okay, So I mentioned that the future API is a minimal API. So it basically contains on the two functions you already seen, the future and the value function. And there's one more function called resolved. That function you might need sometimes, depends what you are, but it allows you to peek and query a future. And basically, are you done yet or not? And it will not block. So you can, if the future is being resolved on a remote computer, that resolve will go out and check, are there results available for that future already or not, and return true or false. But the key thing here is, like, with only these three constructs, we can do a lot of powerful things. And here is the very first example. So you can create your own parallel lapply now using just future and value. You don't have to use resolved. That comes if you want to do more fancy things, but you don't have to. So this function, maybe I should show the example first. So this is how a user would use it. They say, let's, I want to run it on a multi-session that's parallel on a local computer. And I want to do lapply on this list X and call slow sum. What happens in here now, if you look at the inside of a parallel lapply, the slow sum is this generic function, this argument fun. And what we do here is the first step. We use lapply. We could use a for loop here too, but I use an lapply. Over all the elements in X, I call this function with the element X and any optional arguments. However, I do it within a future. So this first lapply call here will now return a list of futures. And when I got that list of futures, I will just say, okay, now on this list of futures, give me the value. And there are several things happening here. If you have enough, if you have more parallel workers than you have elements in X, this first lapply will return immediately. However, if you have more elements than you have parallel workers, it's not going to spawn off much more workers in parallel than you have. So it will hold back. So the future call, if you get to the fifth future call and you only have 4 workers, the fifth call would wait until there's a worker available. But that will just, that's taken care of by the future package. So it's the point here is that it's given these two constructs, it's very simple to create higher level MapReduce parallelization frameworks. And I want to say this is, of course, it doesn't solve everything. It doesn't take care of random number generation, etc., and load balancing. So we need to worry about that, but it will work and it will run in parallel. Okay, so very early on, I added the future.apply package, which basically provides futurized version of all the base R, lapply, vapply, tapply, replicate, and so on. And the only thing you have to do, if you already have code that calls lapply and you figure it's like this takes a long time to run, I want to parallelize it, so you basically load this package and prepend that thing with future underscore, and it will work. There will be cases where it struggles to find global variables, but this works most of the times out of the box. And then again, the user picks, I want to parallelize locally across multiple machines or in a job scheduler. We have also the furrr package by Davis. It provides futurized versions of parse, map, map2, modify, etc. functions. And it's very similar to the previous example. It provides, it works on all parallel backends, load balancing, proper random number generation, And all you need to do is just prepend that map with future underscore and call future underscore map. And if you happen to like the for each framework, and a lot of people discover the for each framework when they want to do their first parallel processing, I have do future backend or adapter to for each. So you basically, all you need to do is register that backend and use do par, and this for each call will now evaluate slow sum using the future framework. So internally there will be future and value and resolve done. And then the user can decide to use whatever backend they want. So point is here, thanks to these three very basic constructs, we can very quickly build up higher level parallelization map reduce APIs. So if you like base R, you can use future dot apply package to parallelize. If you like the tidyverse furrr, you can use the furrr package. If you like for each, you can do this. And there might be other coming. For instance, if you like the now deprecated plier package, it works also automatically through the do future framework. If you use BioC parallel, you can also use do future. So you can use that favorite MapReduce API you like, but you can still run it on top of the future framework and whatever backend it supports. Okay. So let's see. So one thing that's been added over the last 2 years is handling of output warnings and errors. Errors been supported from very early days, but so let's show some examples here. So if we do this, if we do lapply over a vector of -1, 10, and 30, and we inside that function call, we display, we use message to show its value, and we calculate log of that value, we will get this output. We will see it stepping through the 3 elements, and we will also get a warning because log of -1 is not a number. Now, if we use MCLapply, different people will have different success here. But if I recall correctly, if you do this in RStudio, you won't see anything. If you run it in terminal, you might see the output. I don't think you get the warning at all. And this is because both the message and the output and the warnings are generated on the worker, and they never reach your main R session. They stay with that on that other end. That's the same with parallelapply. So, but with the future framework, and that's taken care of at the very core level of futures. So this works with future apply, furrr, do future. Output is captured. Standard output is captured. Messages, warnings, all conditions are captured. So we will get the same output as you would do with the regular lapply. And this output is a real output in your main R session, so you can actually capture it. So here is a similar example where I replace the message with an str, and that sends the output to standard output. And I use capture output. I wrap the whole call in capture output. So this function in R, this is base R in the utils package. It will record everything into variable standard out that it sees on standard output. So when this one will first generate the warning because the warning goes through, but it captures everything from the 3 steps str into a vector. So that shows that the standard output reaches you regardless if this, again, this might run on the other side of the world on a computer, and it reaches you on your end. And that's the same with conditions. So now I drop this str and I just calculate log. And of course, the first element will be a warning. And I can use a try catch on my end. And this warning generated in the remote worker will be relayed back to me. I capture the warning, I bump up this warning to an error, and I get an error. So this is exactly what you could do with a regular lapply. But you can't do this with MC lapply or parallelization or for each. Or you can do it with for each if you use the do future backend. Okay. So can you trust this framework? Am I just telling you all the paradise here, or does it actually work? So there are things that people run into, and we try to solve them, and certain things we can't solve. But I want to show you the way I'm thinking about this development. It grew out of small things that didn't work in MC lapply, parallelization, relaying output, warnings, etc. Features you want to have that adds a lot of frictions if you don't get them. So this is how I think about it. And hopefully that gives trust to both end users and developers. So if you use future apply or furrr or do future or whatever will come around that do high level future frontends, or if you just use the basic future value functions, you can trust that the future API guarantees that regardless of backend you use, if you use the built-in parallel package and the different backends we have there, call-r or batch tools or whatever we get, it will work the same. And how can we know that? So of course, we run a lot of tests. So there is something called the backend confirmation test. So the different backends has to pass a lot of tests. It's similar to the DBI package for databases. There are different database backends, and they run conformance tests for those to make sure they meet all the requirements. So you can switch out the backends. That's the same thing here in the parallel processing. I would say it's very well tested, testing it as much as possible. And if we run into a bug, that bug becomes a new test case, etc. So point here is, as a developer, you don't have to worry. You can use future apply, furrr, do future, and you should just trust that it will work everywhere. And users also, you don't have to say, oh, can I dare to run it on my HPC scheduler? Will I get the same results? Because in the end of the day, the results are critical, especially in statistical analysis. So that the goal here is that the future API will take care of you in this sense. And this the package being on CRANs in 2015, it's been adopted by several bigger packages like Drake, Plumber, Shiny. And so of course, with those, there comes a lot of end users and real world testing. We also get tested on all the platforms possible for CRAN, also on various continuous integration services, testing on old and new versions of R, and go back really far, I think 3.1 or 3.2. Reverse dependency checks is now up to 140 packages. And those tests, I use the RevDep package, awesome package. And I can also, because I'm in control of the future API, I can set an environment variable that I can test across all different type of backends, even if those CRAN packages and bioconductor packages don't test across those backends. I can run their checks with a different backend than they intended, and that way I can cover more cases. I also, from early days, since the for each package has a lot of packages on CRAN uses for each. I think there are like 700-800 packages, and we have like Plier, Caret, GLMnet. So I dynamically tweak their examples, and so they run through the do future backend, and that way it also allows me to run all those packages and their examples through the future framework. So that adds more test cases. And then I mentioned before, there's the conformance validation of the parallel backend. So there's a separate package, future.tests. This was supported by the R Consortium grant before I became a member there, I should say. But this allows you, if someone writes a new parallel backend for futures, they can run these tests and make sure it works. Okay, so let's say, so what doesn't work? So not everything can be parallelized. And by the way, feel free, if there are any questions, break at any times here. I don't know, there might be lots of questions already. So not everything can be parallelized, and you will discover that depending on what packages depend on. But a very simple case is this, connections in R. So here is an example that runs parallel multi-session. We open a temporary file, and then we open a connection to temporary file to write to this. And in the main R session, we write the letters hello to this file. Then the next step, we create a future that adds world to this connection, and then it returns 42. And this will work. We will launch the future. However, when we ask for the value, we're going to get an exception from this parallel worker saying, hey, that is an invalid connection because this connection object is only valid in the main R session. We actually passed it down to a worker where this doesn't make sense. And luckily in this case, it actually detected it's invalid. You can actually end up writing to the wrong files here. R doesn't have a very good protection mechanism for this because connections are basically just index numbers, 0, 1, 2, 3, 4. So if you already have, if this is connection 3 in the main R session, and if you already had a connection worker that is 3, it will actually happily write to that connection. And this is really hard to protect against, but we can try. And this is not just for the future framework. This is true for all parallelization frameworks in R. You can ask our future framework to say, scan for potential problems among your globals. And if you detect that, the potential problem is a reference pointer, throw an error. So by default, it just silently ignores it. And if we had this option set, the future framework will actually, before it sends it over to the worker saying, hey, I detected a non-exportable reference. It's called the connection and it's a class of file. This is not enabled by default, this check, because if you have very large global objects, it might take a very long time to do this, but also there are some false positives. So if you would do, for instance, a data table object, it actually has a external reference pointer internally, but it's fine to pass that object because the data table package is clever enough to fix that when you serialize and send it to a parallel worker. So, but if we had set this to error, the future framework would prevent you to sending that object. So we can unfortunately not do this automatically. Another one, and this is becoming more and more common as more low-level libraries get their corresponding R APIs. So XML2, for instance, do XML objects. So if you create an XML object, say, this is of course a toy example, but if you read an XML file from the web or locally, and if you try to parallelize this, you're going to get external pointer is not valid. And if we look at the content of this object that we try to send over, so it is sent over, but then on the worker, it tried to process it and it doesn't make sense because it contains external pointers. And those are only valid in the R process where they were created. There is a vignette for the future package that try to do a collection of all common cases. So if you discover new ones, I will be happy to add those there. And the way how we resolve this, in some cases we can work around it. If you want to parallelize over this object, of course, I think the only thing you can do is to read this object, use read XML within the parallel worker, because you can't export this. Other cases is like you can work with the package developer. They might not have thought about it, and maybe they can come up with a workaround just like data table does. The scary part here is that there are some cases where you don't, the package that actually creates this and uses it in parallel worker doesn't detect this. So you might actually core dump the worker, and even worse case, you actually get random results back. So if anyone out there knows how to protect against that, I would be very happy to hear about that. Okay, so roadmap, what's on the horizon here? Thing that's been asked for from day one. It's you launch things, you launch big jobs, and it takes forever. You launch maybe 10 parallel workers, and you immediately discover, oh no, I did a mistake. I want to restart it. There's no way to terminate those launched futures. It's a bit philosophical, because it's basically the future API doesn't have a concept of a worker. It only has a concept of a future. But there might be ways to get to this. And one here is a mock-up. It doesn't exist, but can you imagine you have you have two functions that perform the same calculation, very slow, and another one called also slow, but you don't know which one is the fastest. So if you can spare the cycles, you can just launch this in parallel at the same time and just see which one is ready the first. So if you launch this in parallel and you say, hey, you check future 2, are you done? And if it's done, yes, collect the value. And then here you want to say, now I'm no longer interested in the first future. So we need a mechanism to say, discard the first future. And depending on the parallel backend you run, this might be able to actually terminate that, interrupt that future, and free up those CPU cycles. And but it might not work too, because it's yeah, maybe you could work this terminate a running worker on a remote machine somewhere by SSH in the background and sending a interrupt signal. It could also be that this we run futures in Linux containers are sandboxed. So as soon as we launch them, we can't reach them. It's like a security thing. So you might not be able to tell that Linux container to stop. You just have to wait for it to finish. This are things I'm thinking about, but it takes a very long time to get to. Every new release, there's something updated internally towards these goals. Another thing where this, like if you can terminate futures, is like if you use a MapReduce call and one of the elements gives an error, then that future call will return, that MapReduce will result in an error. And there's no point in having all the other elements, chunks, keep running. But in today, how it works now, we just have to wait for, in this case, the slow 42 and slow 31 and slow pi work, whereas the slow of the string pi failed. So it would be nice if you can detect this and terminate running workers and throw the error then, and just be more efficient. Another thing that is also, I wish we can figure out how to do it, and slowly we're getting there. So if there are, I call it extreme events. So when we do parallel processing, you will run into things like internet goes down. So you lose the connection to that remote worker. So that worker is gone. So if you try to reach that later, you get a non-communication failed error. You can have power outages. If you run big HPC clusters, there might be other users running on the same machine, and they might run some software that brings down that machine, so it has to be rebooted. And then it's a bummer if you have to, you might have been running things for days, and if one of your futures fail, how do we handle that? So the future package detects those types of errors when it can't communicate. And here is an example. If you actually launch a future in the background and call quit, this can be done. And of course, that will quit that background worker's R session. So when we ask for the value, there's no longer a communication with this background worker. And the error will say, yeah, the process ID no longer exists, and I conclude the process died. And we can use those as, we can catch those for exception handling. They're for future error class. And the thing is, what can we do here? Ideally, should we restart the worker if it's a power failure? Can we relaunch the future? And then the question is, what does it mean to relaunch a future? What does it mean to restart a worker? Because that concept doesn't exist necessarily in the future API, but maybe it exists at the parallel backend. And other questions like, how should these type of errors be handled in higher level map reduce APIs like future apply and furrr? That's not clear. It's a design question, philosophical question, because in the end of the day, we want everything to work as similar as possible as it would when you run sequential code. So, okay. Another very common question is to pre-populate workers with data. And this is one place where futures don't cover that case because they don't have a concept of a worker. Because future can be sequential, they can be in parallel. But here's an example. We launch 4 parallel workers, and we have a very huge object. And we're going to do calculation on that object in parallel on the workers many times. So the most efficient way is then to export that object once to the cluster workers. And then we call parallelization for a certain set of parameters. And then we call it again with another set of parameters. And the nice thing here is like, we only need to export huge once, because this might be a substantial portion of the parallelization overhead. So we don't want to keep re-exporting it unless we have to. So as I said, by design, the future API doesn't have a concept of a specific worker. So we never know where a future will run. We don't know. A lot of parallel backends are not persistent. They, like the call are, they launch a process, evaluate the future, and shut down. So there's no worker to cache things over time. But so when you use future lapply, for instance, a furrr map, in this case, the object huge will be exported each time here. So that's unfortunate. Trying to come up with thoughts about how to do this so it fits the model. And one is something called sticky globals. And basically, you might be able to specify future cache huge. And maybe there we can have a language construct, but basically you tell the future, which ends up on the worker, saying, feel free to cache this object if you can, if you have that feature built in. So the next time we call it, if the backend has this object cached, it would, the framework will not send it over. And of course, you can imagine there's going to be negotiation. It's like before exporting this object, it will calculate some checksum. It will communicate with the worker. Do you have this object cached? And they said, yes, I have this same object with same checksum. You don't have to send it. No, I don't have it. Send it over. So that kind of infrastructure has to be added. And on the developer's end, it has to be encapsulated in very, very simple constructs that works regardless of parallelization backend. So this is another thing, work on the roadmap. Okay, so let's wrap up. If you're interested in trying out parallelization frameworks, feel free to try the Future framework. It's a 15 years of trying to improve on the existing things. Mostly worry-free. You will run into some things. And if you do, please ask and we'll try to help you. It's meant to be write once and run anywhere. Global variables automatically taken care of, same as packages. Standard output messages, warnings are automatically captured and relayed. Here I mentioned progress too. I have appendix slides, but we can save that for later. That actually shows that you can do near live progress updates. So you can have progress bars, etc. through a package called Progressor. Users are allowed to decide on what their compute resources are. So if you write your code, as long as it does use futures for parallelization, that user can use big compute clusters or the cloud or whatever, your code will work there. There are some, it builds on atomic building blocks, 3 different, the future, value, and result. And from those 3, all the higher level parallelization APIs are constructed. And it's 100% cross-platform. Thank you. If I stop sharing.
Thank you very much. Does everyone have a big virtual applause for Henrik? I'll do my little bit. I'll try to get near the microphone so everyone can hear.
Thank you.
I hope everyone had a great time. I learned a lot. I've been using parallelization for a long time in R. I came up using the, I knew Steve Weston, he wrote Parallel and do Parallel. So I was using his stuff. I know we unfortunately lost him this year, I believe.
Yeah, it's his work is amazing.
Yes.
I didn't say that here. He laid a foundation of these thoughts and models of thinking about it.
Yeah, he really did. And where I learned of Brian Lewis had to sit over my shoulder, and because he was really good friends with Steve, sat over my shoulder, like, do this before each, do this, and really walked me through it and really expanded my knowledge. And since then, I've been using Future and everything. It's really nice to see where we've come. For those who don't know, Steve Weston is from, I want to say, the New Haven area, Connecticut. He wrote the Parallel. I'm not sure if it was the Parallel package or the do Parallel, the various types of Parallel. Henrik, you probably know more than I do.
He wrote the for each, and then the do Parallel came with those, yeah.
Got it, yeah. And that was revolutionary. And that was the only really great way to do Parallel, 5 years ago until Future came along. So we have a bunch of questions. So we'll see how many we make. I didn't interrupt you in the middle because you're in a flow, and I figured, okay, let's keep going. If more questions come in, I'll add them to our list. So you had an example where you have you wrote your own parallel lapply, and you said that at the end of it you had lapply of fs comma value, where you call value on the whole future objects.
Mm-hmm.
Now, because when you did the first lapply in that function, it returns instantly. Now, when you do value, is that lapply running sequentially? And if the first one is blocking, all the rest don't show up yet?
That's a very good question. So that's yes, it does, of course. If your very first one takes the longest, mm-hmm. you can't collect the values on the other ones. So you have to wait. You pay that overhead of collecting values. Okay. And if they're big objects, it might take some time. That's where you want to use resolved. So you want to check in on those future. Are you done? Give me the value. Otherwise, I go to. So behind the scenes on furrr and future apply, there's a lot of this orchestration going on.
So that's going to be the next question. That takes care of it all. Like, imagine there's a while loop and checks resolved and then collects them. And if we use future lapply or future map, we don't have to worry about that.
Exactly.
Wonderful.
And that same for loop also, which was major work last year, this standard output, when it relays it, It's trying to relay in the same order it was created, the same order as the loops are done, which it does, but it also tried to do it ASAP. So it's a lot of tallying there going on.
A lot of things that hopefully the users don't have to think about, hopefully.
Yep.
Since you just mentioned, this actually segues into another question. Any discussion about the differences, the merits between future lapply versus future map?
I think that goes more to the way they work now. That's like asking like lapply versus purrr. That's what it comes down to. And then they just happen to run in parallel.
Okay, so, that was going to be my guess. All right.
Yeah, and that's where I wanted the future API to go one day. It's
All right.
Yep.
I guess along the same lines, can you compare? I guess it's probably going to be the same answer. Can you compare do parallel with do future?
I can. So do parallel is it does either the MCLapply framework internally or the parallelization, and it's a bit unfortunate. It checks if you're on Windows, it does one and the other one. And the future framework had that until last week. We had something called the multi-process, which did multi-core if you were on Linux and Mac OS, or multi-session on Windows. And finally, we decided that's not a good idea because it's too ambiguous. So do parallel has that same thing, but that's a minor thing. So do parallel has the same strength and weaknesses as MCLapply and parallelization. Whereas if you say do future, it will take care of the output and the warnings and the conditions. It will also take care of globals. This is something I don't know if it should. So it's actually an option. No, because if you write for each code, Steve Weston's idea is that the user decides on the backend adapter to register. So if I write code that the future framework takes care of the globals, then the developer is sloppy and assumes that it will work. Then the user uses another backend, do parallel, and it won't work. So this is the discussion we have to have with the for each developers, and I had it slowly over the time, and we're trying to merge things there, but it's so I think you can. I mean, since I wrote the future framework, it's like I think I used the do future.
Okay.
Yeah, but it's.
And then I guess someone has a good pun. What is the future of parallel, or the parallel package?
That's a good question. It's a good pun. It's something I'm working on in parallel. No, but it's there are certain low-hanging fruits. I don't know if you check in the RDevel list like a few days ago. I actually extracted a lot of things from the future package to a package called Parallelly, because there are a lot of small, low-level orchestration that I think should be done by parallel package, which I just did in the future. So I took that all out from the future package to separate package. And by doing that, I hope some of those will slowly get into parallel bug fixes and stuff. But I mean, the parallel package has a lot of great ideas. The parallelization has a lot of great ideas. And for me, working with this future framework in 5 years, I tried to reverse engineer Luke Tierney's thoughts. And I can see he has a lot of great thoughts in there too. But we don't have a common de facto standard how to use it. So unfortunately, there's like different ways of using it. But okay. It's a great package.
I think for new users, I'm going to guess future is going to seem simpler to them.
I hope so.
Yeah. And you mentioned multi-process. I'm going to go back to that because I've realized I've had some issues with using multi-process in our Markdown document in our studio. This was a few months ago, and I'm assuming that you've gotten rid of multi-process to avoid those types of issues. So I guess I'll segue to another question here. How does all this play nicely in an R Markdown doc in general, since I know multi-process caused issues? Let's say you're writing an R Markdown document, you're on a Windows machine, but you're deploying to a Linux machine. How do you get this stuff in there to run in parallel on both your machines?
I'm not sure I understand the question. So it's, if you have within the R Markdown, you just have parallel calls, that would just work.
Like
But are you
future
saying,
event.
yeah, that will work. If you're saying you send off to process the Markdown object in a parallel?
I think the question was in a single Markdown document, if at the top you say library future, plan, multi-session or multi-core, and you want this Markdown document to work either on Linux or on Windows, is there a way to do that without your own? Because it used to be multi-process.
Okay, yeah. I mean, so then so because of that whole thing with the forked processing might be unstable, we recommend, and I say we, it's me and Davis now. He came to the same conclusion. Is like it's nice to document and show one line, but it's a bit ambiguous, and some people might run into problems that others don't. Okay. So use multi-session. Multi-core you should only use when you really know it works. And I want to say that if you write that Markdown or R script or R package using multi-core, and you call another package, and 2 years from now, that package introduced some multi-threading or something that causes multi-core to crash, you have no control of that. So so avoid multi-core.
That actually brings up a great question that you triggered. I know I've had situations where data table, which is multi-threaded, has crashed hard on me when I'm doing that in parallel. I think now data table automatically detects if you're running something in parallel and turns off multi-threading. Have you seen that?
I didn't know they got to that far. I was so I'm a big proponent of saying run everything sequentially by default, because more and more things are running in parallel, and we might actually fry the CPUs if we're not careful. I should also say that, as you might know, the future framework tried to protect against that, but you can't do too much. But that's cool if they manage to detect that, if they see if you run in a fork or a child process, that it falls back.
I read that in some forum somewhere that they start detecting exterior parallelism to turn off their internal one.
Oh, that's brilliant. It's we've been playing around. There's an optional thing. I forgot exactly what that package is called now. It can disable the what's it called now? OpenMPI. Not OpenMPI, OpenMP. So if you do future and it runs on another computer, you already parallelize on 8 cores, or on another core, 8 cores. Then it tries to set those to use one thread if it can. So it's trying to be very conservative.
And I have an issue. I have like one machine, well, a few machines actually, where I use software-defined networking, which is a VPN, but like it's a peer-to-peer VPN completely defined by the software. And if I ran things using OpenMP and it took over all my cores, I lost connection to that machine because there's no compute left to actually run the network connection.
Wow. Yeah, that's Yep. And then and you don't want to discover that after 4 days of processing.
Or when your machine is in a physically different location and you can't get there because of COVID.
Yep.
Yep. Happened to me a lot until I finally relocated the physical machine. It now sits under my desk for now.
Yeah. No, there are a lot of interesting things when it comes to distributed and parallel processing to get things robust.
Which is a nice segue to another question. Can you do nested parallelism, as in federate out the different machines and have each of those machines use multiple cores?
Yes. So I didn't show that. So I've been using that a lot in my cancer research. So we have a compute cluster, one with 2,000 cores, which is like 30 machines. We have another one with now 10,000 cores. So I have the first layer of parallelization. It can be, for instance, if I have 100 patients and I want to run analyze the genome across the 25 chromosomes, I use the first layer of parallelization across patients, and I throw that out to the job scheduler. So each patient becomes a future that is submitted to a job scheduler, and the job scheduler will then launch that future. And internally, when I do that, I request I want to have 25 cores. So when that future launches, it will run 25 local cores wherever it ends up.
Okay.
So that's a case where you do nested parallelization. You can specify that with the plan function.
Oh, using tweak or something, right?
Yeah, or so you basically can specify a list. So you can do a list of, so by default, it's only one level.
Mm-hmm.
And if anything below becomes sequential if you don't specify. So you can do a list. In this case, a first element in the list is a batch tool backend, and the second one is a multi-session.
Nice. That's really cool. And do you have an example on? I've seen an example somewhere that you say that, but I've seen you have a sample somewhere.
I definitely have, and I can probably pull it up straight away. It's give me here. Yep, I'm going to share my screen quickly.
Great.
Here is an example. So as you said, there's a tweak. So this is actually not in a scheduler. This is saying a cluster of a predefined set of nodes. So I call that an ad hoc cluster if I have access to 50 machines myself and no one else got there. So the first layer saying allowed to use a cluster of these machines. And then the second layer use multi-process. No, that's this is an old slide, so it should be multi-session. And there might be other things, but the idea here is this is using the future assignment. But here is like an outer loop over fast queue, that's the patience. And then here I create my first future, this one. So that will now be launched on one of these machines. And then I run over 24 chromosomes, and each of those runs in a second level of futures.
Very nice.
Yep, that's how it works.
Very cool.
Thank you.
Thanks for sharing that. All right, let's see what else we got here. You mentioned that you test on Solaris. Didn't Cran Solaris die?
But they revived it, I think.
Oh, they did.
Yeah, it's I'm not sure if they actually revived. It might be in modern versions, so the big engine, little engine thing might actually. I don't know. So I know that's a debate. It's a pain when you get hit by those, and yeah, it's very frustrating at times because it's really hard to reproduce, and you can't just like trial and error. You can do that a few times, but somehow I do things so like have testing on very obscure environments actually improves the quality for all of us.
I do believe that. I know a lot of people cheered when the Solaris machine died.
Yeah, and there is the RHub service provides Solaris, two different.
Oh,
yeah, so it's, that's where I can test more live.
Okay. Yeah. Didn't know so many people are using that. It's, cool they're still using it. There's this question from our next month's speaker, I believe. But you already answered. He said, how exactly does one automatically detect a non-exportable reference? But you answered that, he said. So it was in the chat. I just wanted to let you know that he asked that and that you already answered.
I mean, but I also tried to say is like, I can't, but in most cases, the ones that call external pointers, they fail, but they don't always fail. So, and you can scan for external pointers when you, for the serialize function. So when you call serialize, you can do a hook function. And as soon as the serialize detects the external pointer, it calls the hook function.
Okay.
So that's how I do it.
Oh, well, hopefully that that influenced a little bit. So when you're doing parallel processing and you get an error, and it seems like it gets captured, and it doesn't. Not everything stops. So like if you do lapply, you get one error, the whole thing stops. This thing doesn't stop. So let's say you have 5 elements in your returned list, one of which is an error. How does that show up in the returned list? Does it show up as an error object? Is it just not there? Is it an element? Is it a 4-element list now?
So this, I mean, this question is for future apply, and I guess the same for furrr, and also for each. So this is more a design thing. It's like, so if you ask the same question for lapply, what would the API for lapply be of saying, I want everything to run? How should but how should, what other arguments should there be or options for returning one error out of 100? So that's a matter of designing how that should look like. And right now I took the easy part and say future apply package emulates the base RL apply and etc. exactly as is. So I don't have to worry about that. Someone else can maybe figure out how we extend that. I think furrr, he takes the same approach. He's like exactly like purrr, because if you start adding features,
Right.
then someone say, hey, I want those features in purrr or lapply. So we need to be careful there. So I think one solution is in the for each package. They have, forgot what the argument is, but there is like on error or something. You can choose to throw an error. I think that's the default. You can also say ignore it, like drop it, which is kind of weird. So if you expect 100 values, you get 97 back. Yeah. You don't know which one you don't get back. And then there is also return the error object. So I think that might be a solution to bringing in handling these kind of errors for large processing. Then but then the next question is like, how do you bring in the concept of orchestration errors, power failures? That's another type of, who should take care of those? And then people start asking, can you automatically retry? And maybe we can, but you don't want to keep retrying till the end of the world. So you need to like maximum 3 retries instead. So it's complicated to design an API for that.
Yeah.
But yeah, but hopefully if we don't come up with it, someone else can figure it out.
Open source.
Yep.
We have a question about, they would love an explanation on the difference between futures and promises. They're familiar with promises from JavaScript and they're trying to resolve the terminology difference. Because I know there's actually a promises package and there's also an R promise object, which has been in R forever. So I think that's what I think they might be coming at a few things here.
So it's a good question. So in R, promises, so I don't know JavaScript, but I'm pretty sure that it's not the same type of promise as JavaScript has. So let's leave aside the promises package. So the concept of a promise in R, we kind of actually use quite often, I think. If you want to look at it, there is a function called delayed assign, or delayed assignment. So I can say, calculate 1 + 2 and assign it to variable A, but do it through a delayed assignment. Then what happens in R, that A doesn't hold the value 3, it holds a promise to calculate the expression 1 + 2. And that is a construct deep down in R. And that, I think that allows it to do various kind of lazy evaluations. So you can set up like A 1 + 2, B this and this, but if you never use A and B, you don't spend time calculating them. So it's just like when you ask for the value, it will resolve it. So the promises package, I think, is more like the JavaScript, which I think has these like, so I think it's an unfortunate name in that sense, but it probably fits better into the graphical user interface with Shiny. That's why it exists. So the promise is there, and that can be used with futures. So you can create a future that uses the promises package. And yeah, you can probably see my hands, yeah. I don't know. I was waving when I gave my talk too, I don't know. But it's so there, underlying the promises package is actually an event loop running too, which is in a package called later. So it is really cool. It's also very scary, but that's required in user interfaces like Shiny. So it actually loops over this promise and see, is it done? When it's done, it resolves it. Or it's yeah. So it's, sorry, I can't give a good explanation for that. That's Joe Cheng should explain that. Yeah,
we'll get him here one day.
Yeah,
we will. Yes, he's long overdue for a talk. Then, do you know how plumber uses future? So one of your slides just showed it. So someone's asking, do you know how plumber does it?
I actually don't. I never launch plumber myself. I know it's a dependency, and my reverse dependency checks, I run it every time. So it's, yeah.
All right, then the similar question, do you know how the Tidy Models tune package, what backend it's using, if it's using? So I've talked to Max about this,
Yeah.
and he said I could either use do parallel or do future, but do you have any more insight than that?
I don't. I mean, the carrot used for each, so
Yeah.
he might go on there, but he has Davis who wrote
Exactly.
furrr, so who knows, he's sleeping over there. It's yeah.
I mean, Max uses underscores now instead of camel case, so.
I mean, I don't know if you saw my slides, but I used to be very picky about naming conventions. And when I started R, you couldn't use underscores.
Yeah.
It's that old.
They were
So I came from the Java world also. So I was like, okay, camel case, which by the way is better for screen readers, I heard.
Yep.
But so I used camel case, and then I started to use underscores, and now I'm one of those people that has a mess sometimes. So sorry about that.
Yeah, both capital case and underscores together.
No capital case in the beginning. I think no, not yet.
Yeah,
except classes. Classes are capitalized like Java.
Yep, like Java.
Yep.
I've definitely been guilty of combining in one variable name both camel case and underscores for different parts of it because they explain different things.
Yep.
All right, just a few more if you still have energy and time.
I have energy. These are brilliant questions. It's fun.
Someone's asking, they must have saw it somewhere. What is future.magic?
What? Magic?
Maybe they misread one of your slides.
Was it in the slides or was it like on the interwebs?
I have a question. Someone asked, what is future.magic?
I mean, it could be. Maybe I wrote that.
I think, you know what? I think maybe it was like when you're showing some of your tests or reverse dependencies, I think I vaguely remember seeing something there. I saw future.something.
Wow, I don't know.
Okay.
But maybe, yeah, I mean, maybe it's one of my magic future packages.
Fair enough. We have a question about why do you suggest not to use detect cores for MC apply?
Okay.
And someone does say they saw magic somewhere in one of your slides. Someone says her name starts with an A. Just said that.
Maybe
Mala said that.
was it the presentation I did today, or was it this different one?
Someone today.
Oh, future. Okay, let's see, magic. Maybe it was the magic pack. No. And then I showed this. No, I don't know.
All right, so someone had to hunt you down and email you. So the other question that someone asked,
parallel or detect
cores. Why do you recommend not using detect cores?
Okay, okay, I'm not sharing my screen now. Let me quickly put that up. It might be easier. So detect cores is it hijacks all the cores on your machine. Okay. So that's fine if it's your machine and you're the only one. And then there is a pattern where people say, you see that very common. You see it in our packages saying, let's leave one core aside so I can keep working. So it's detect cores -1. So just that is actually two problems. First of all, there are machines with only a single core. So if you do detect core -1, you get 0. It's not common, but you can have that. Another one is detect cores. If you read the help, it can actually return NA. So you have to handle that. So you have to do something like max 1, detect cores, NA RM equal to true. So you cover those cases. Okay. Then you submit this package to CRAN. And if you read the policies, they say don't test on more than 2 cores at the same time. And if they have now 16 cores and they might run like 5 packages tested at the same time, you might go under a radar. until someone discovers it and they yell at you. And then, however, then they get more and more cores, so they might run on 128 cores now. And then they fit more packages at the same time, and more packages run parallel code at the same time. So there might all of a sudden be like 10 packages running detect cores equal to 128, and they're going to swamp that computer. So this problem of using detect cores in a multi-tenant, multi-process environment is getting worse and worse and worse. And why I feel so strongly about it, because I'm at UCSF, I'm in the different compute clusters. We see software, R, Python, that trying to be fancy and default to run multi-core and takes all the cores by default. And it's super neat when you sell it and you show it and you run locally. It runs very fast and people want to run it. But if you have 20 users on the same machine, it's going to fry the machine and no one will be happy. Sysadmin will spend a lot of time trying to figure out what's happening. They have to like look at code, and it's hard to reproduce and things like that. So it causes a lot of headaches for sysadmins. So yeah, don't use that. And then now as a salesperson, you should use future available cores, which I now moved to parallelly, but it works still in the future. So that works the same as detect cores, but it will also respect various settings. So if the user has set MC cores, for instance, to 2, available cores will return 2, whereas detect cores will still return 128. The sysadmin can set an environment variable. Of course, they have to know about the future framework. They're saying by default, it should run 1, unless the user requests more. But more importantly, available cores also respect various schedulers like Slurm, SG, Torque. So if they gave you run a job and it gave you like 4 cores, available cores will return 4. And on CRAN, it will detect that it runs our command check and it will only return 2.
That's nice.
So you won't mess up on CRAN.
Nice. You don't want to do that.
Yeah.
And then speaking of cores, there's actually, I have a follow-up question on that. And actually now it's a 2-parter because you mentioned something. I know that I've seen Max talk about this. From a lot of machine learning algorithms, once you get beyond the physical cores, the virtual cores don't give you much return on speed.
Yeah.
How does futures deal with virtual versus physical? And also, have you seen with detect cores, even if you say logical equals false, it still gives you the count for virtual instead of physical cores?
So available cores only does what detect cores do. You can, I can't remember if you can ask it to give logical too. This is something I don't know enough about. There's like all this hyper threading and everything goes on there. I think the only way there is like to actually test it, but it's hard to test it in multi-tenant environment. You have to test it in a, it would be nice you could have some learning algorithm. So one thing I want to build into the future framework is to optionally benchmark things, so you can see how much time it's spent waiting for things and orchestrating, and if you could pull that data out and summarize it, you could maybe run it with 1 core, 2 core, 3 cores, 5 cores, and see where on your machine what's the best one.
That would be nice. So again, Max has done the benchmarks on machine learning algorithms. That's Max's specialty, and he's definitely shown, especially for tree-based algorithms like XGBoost. Once you get past the physical cores, you're just wasting cores at that point. Which begs the question: can you do 2 XGBoosts, both running on all physical cores, and get the same benefit?
Oh, yeah, if you parallelize and run, I don't know. It's a very good question, but yeah, I don't know.
That's for him.
Yeah.
All right. And this is someone's asking about registering backends versus plan. Like, do you still need to do any sort of, like, with all the different plans, do you have to do register do parallel, register do future for anything like that?
So you have to do that with the for each. Let me show that. Can I show this? Maybe I don't have it. So when you do when you load a do future package, it doesn't do anything. So it doesn't tell by default for each that, hey, use me now. Seems to be the standard to say you have to register that. So you do register do future. So with that will tell for each framework, everything now should go through the do future package. And the default in the future framework is sequential. So then you have to specify plan multi-session as well. So it's 2 lines. I thought about having like do register and then put the plan inside. So you can do 1 line to call this, but that might be too confusing. Yeah. So with the do future, there's no argument to it. You just say register do future, and then you set the plan.
Okay.
Yeah.
Now, and you only need to register a future if you're using for each. If you're using future lapply, future map, you no longer need to register.
Yep. So all those register functions are only for the for each framework. Yep. Cool.
That answers, we had 2 questions that are similar. This one is a lot longer. And this actually, the last one I have record of, unless someone else asked, is the last one I have here. Some they really like the package. They are having trouble doing it successfully. A large part of it is they're getting an error that's along the lines of restarting promise evaluation. And they're wondering if that has something to do with using RMySQL. So trying to load in a lot of data, and they want to use like future of DB get query of some query. Basically, I guess I'll distill this to, what is restarting promise evaluation, and have you tried using this for reading databases, and how type of issue is that?
So the restarting promises, I don't know where that is coming from, but I suspect that you can't parallelize database objects. That's my best guess. I'm going to pull that up now.
I guess you could create the connection on each worker instead of creating one global connection.
Yeah, so now you see my thing. This is from the vignette non-exportable objects.
I've read that.
And one of the examples, DBI connection. I mean, it might not be this, but basically, here's like you set up a DBI connection and then trying to parallelize over this. And this is just saying, print the connection over in the worker, and it will just not work. Here I'm detecting the error. I don't know if you actually let it run on the worker. It might completely core dump.
The Drake package talks about this, about how to do this. I remember.
Yeah. So there's probably like, you have to launch. I can imagine you have to set up the connection on each worker to work that around. And then you have to make sure your database is parallel safe, of course. So for instance, I don't think it's safe to use it on a SQLite file because I don't know where you can trust multiple workers to write to the same file in a safe way. Maybe it can be
Postgres. Postgres does its own parallelisms. Imagine you're calling Postgres in parallel and it's doing its own parallelism. You get that race condition again.
Yeah, but I think, I mean, the big databases, they can handle actions or tasks from multiple sources, so they should be parallel safe.
And actually, we got one more question in, which actually seems like a nice way to end this. All this parallelization sounds tricky. Should it remain a last resort?
That's a very good point. Yes. I always say, don't use parallelization. Should I end there? No. No, but I mean, you have to be, there's a lot of things that can be made faster, and a lot of code can be made twice as fast, and it can be done so recursively if you spend a lot of care. But at some point, it's like you want to parallelize, or you might not be able to optimize the code you call if you use another package. Yeah, save it as a last resort, but don't be afraid of it. It's getting easier and easier.
I like that. I'm actually, I am giving a talk at our conference I talked about next month about taking a problem and combining data table, parallelization, and RCPP to take something from hours to seconds. But it took all 3 technologies.
Yep, that's a very good example. It's like,
And I did try parallel first because that was actually the easiest for me to do, believe it or not, versus data table and RCPP.
Yeah.
Cool. So with that, There's one more comment saying optimization about parallelization is tricky. Yeah, I'll buy that. Everyone just says buy more computers of Amazon. All right, anyway, so thank you very much for this excellent talk. I know I had a good time. I hope everyone else did too. Everyone remember, we have our R week next month. We have a meetup, we have workshops, we have 2 days of conferences. If anyone wants to attend, NY HackR gives you 20%. If anyone has financial difficulties, just message us and we'll make sure we can get you in there. Amada, am I missing anything?
And also, if you can also check out the Diversity and Inclusion Scholarship on rstats.ai/gov. And if you are an artist, you can submit something to the art auction.
Yes, and again, the proceeds go to our foundation. So like everyone wins. You get cool art, and our foundation gets money, and the artist gets to have their stuff shown away. And we get some really cool artists on it. I think Thomas Lynn Pedersen is donated something. Is Vivian Peng doing it again?
She might, and we have Nadia Bremer, Will Chase, and a few other, Selena Carter. Yeah.
Nice. And that's on top of all the excellent talks. And by the way, Andrew Gelman, who we all know is this hotly charged political scientist, will be giving a nonpartisan, politically charged talk. We have someone from NASA. We have, oh my gosh, all these names are escaping me. If you go to rstats.ai/gov, you're going to see all this great lineup of great people. It's going to be a fun time. I always like saying our conferences are always fun and informative. Yeah. So it's late on the East Coast. It's later in Europe. Well, it's not late. It's depending on how you define late. Anyway, everyone have a great night. We'll see you all next month and ensuing months. Big round of golf clap for Henrik. Thank you very much. That was really excellent. And hopefully we'll see all of you at our next meetups and next events. And hopefully, Henrik, you'll keep joining the community. In fact, the reason Henrik spoke is because he came to a talk. I saw him in the chat window and I said, you're giving a talk. And that's what happens sometimes. I think Will is speaking next month. He was at the same talk. I said, you're giving a talk. That's what happens. So if you want to give a talk, say hi. Or if I find you in the comment section, he might come after you. So please do join us. And if you want to give a talk, let us know. We're booked for a few months, but we could book you a few months in advance, give you plenty of time to work on this talk. We'll see you all soon. Thank you, everyone. Good night.
Thank you so much.
Thank you, Henrik.
Thank you.
Bye.